Hi everyone, we are doing some close-to-present process of neural network in machine learning. We are using Keras package to build a neural network model, but Keras is not a registered package in Julia, so we use PyCall to build a Julia wrapper around the Python neural network library Keras. The code in the first cell is basically build an environment of Keras. After successfully set the environment, we use pkg.add to add Keras and the static package to use. And in this project, we need dance and activation. So we need to import these methods in Keras layers. Different layers may perform different kinds of transformations on their input, and some layers are better suited for certain tasks than others. Now, we are able to set the neural network model by sequential model API. The sequential model is a linear stack of layers. You can create a sequential model by passing a list of layer instances to the constructor and also simply add layer via the add method.
This model needs to know what input shape it should expect. For this reason, the first layer in a sequential model needs to receive information about its input shape. Only the first layer needs to do this, because following layer can do automatic shape inference. Input shape is a shape tuple, which is a tuple of integers of non-entries, where none indicates that any positive integer may be expected in input shape. The batch dimension is not included. In this case, we are creating 2D layers by names, and which support the specification of their input shape via the argument input dim. Here we set the input dim with 700. Now here is where we add the input layer and the hidden layer with their activation. We added the input layer with 18 neurons and the hidden layer with 10 neurons. The activation function of the input layer is ReLU, and the activation function of the hidden layer is softmax. Before training the model, we need to configure the learning process, which is done by the compile method. It receives 3 arguments. First, an optimizer. This could be the string identifier of an extending optimizer or an instance of the optimizer class. We use SGD, which refers to stochastic gradient descent optimizer. And the second one, last function. This is the objective that the model will try to minimize. Here we use categorical cross entropy. And finally, the third one, a list of the metrics for this classification problem. We want to set these 2 metrics accuracy.
Now I'd like to talk about the fit method, which is what we train the model for fixed number of epochs. Epochs are iterations on a dataset. We need to specify a fixed batch size for the input when we use the fit method. Here we set epochs to 100, which means we use 100 epochs to train the model, and the batch size is using a default to 32 in Python, which shows the number of samples to grind update. The last parameter is verbose equal 1, because we want to see the progress bar. So if you don't want to see anything, set this to 0. We also need to mention about overfitting. So in this test, we find we know overfitting always occurs when our model becomes really good at being able to classify or predict on data that was included in the training set. But it is not good at classifying data that isn't trained on. So we can know overfitting based on metrics that are given for our training and validation data during the training process. So we can find there are 2 types of data, the validation accuracy and the training accuracy. With the consequent results, we can find the loss was becoming more and more less, and the accuracy is more and more high. So if the validation accuracy worse than the training accuracy, then we indicate that our model is overfitting. There is also another way to define overfitting, which means that during training the model metrics were good, but when we use the model to predict on test data, it is not accurately classified data in the test set.
To check the model is good or bad, we need a set of testing dataset to check it. In the test mode, here is input data, and here is target data. The calculation is carried out in batches. Here batches size is 5, and then it returns the error value and the evaluation standard value. In our evaluation, the standard value is about 0.2, so it's small, so we can get the conclusion the model is okay. Then we can use this model to predict other data set. For example, we input a data set, then we can get the 10-by-10 array, like this.
Finally, I want to show how does the neural network model works with this picture in our summary. This picture simply shows one step from the input layer to the hidden layer. In the model, we set the input layer with 18 nodes and the input dimension is 700. And we also need an activation function to transmit signals down to the hidden layer. In this picture, we use value as the activation function, and it just shows that there's one node in the hidden layer. But in fact, like the multiple hidden layer model in the right side, the hidden layer contains many nodes. This picture in the right side shows the signals are transmitted from the bottom to the top, and finally we will have an output here to evaluate and test with. So that's all. Thanks for watching.